You are listening to The Vocal Technologist. Spoken tech for your ears.
You know, if you feel like you need a crash helmet just to keep up with the pace of AI advancement right now,
Oh, absolutely.
you're definitely not alone. It feels like every single day there's a new model or some terrifyingly huge valuation.
Or a coding agent that can apparently work for 24 hours straight.
Exactly. It is a lot to process.
It really is.
So our mission today is to try and cut through that huge wave of information. We really want to zoom in on high-stakes competition between these frontier models, the infrastructure behind them, and this is the crucial part.
Yeah.
How the focus is shifting so fast from just general chatbots to these really specialized, outcome-driven tools.
Right.
We're going to try and pull out the nuggets of knowledge, the true voices shaping what's happening.
I think that's the perfect way to frame it, because what we're seeing, it's not just a tech race anymore.
No.
It's a full-scale economic and infrastructural war. I mean, the amount of money being thrown around is staggering, and it tells you one thing. The big players think the finish line is nowhere in sight.
Okay, so let's start with the money, because the numbers are getting hard to even get your head around.
They really are.
Elon Musk's xAI, the company behind Grok, I'm hearing they're in advanced talks to raise $15 billion.
$15 billion. And that would push their valuation to what? Something like $230 billion?
A massive $230 billion. I mean, to put that in perspective, that's bigger than some of the world's largest, traditional companies.
And that's just one player. Look at Anthropic, which is arguably even more focused on the infrastructure side of things.
Right. What's their number?
They've hit a valuation somewhere in the range of $350 billion. But the real story there isn't just the valuation, it's the hardware commitment.
Okay, yeah, let's unpack that, because this is where it gets really wild.
It is.
Anthropic isn't just taking cash. They are committed to buying $30 billion of Azure capacity from Microsoft.
$30 billion. And on top of that, they've contracted for up to 1 gigawatt of compute capacity with NVIDIA.
A gigawatt.
A gigawatt? That's enough power for a medium-sized city. All of it just for training and running their AI model.
That's incredible.
It connects right back to this infrastructure war we're talking about. The goal is total vertical integration. It's not just about buying chips anymore.
No, it's about co-designing the entire supply chain.
Exactly. Microsoft co-designed its new AI superfactory with OpenAI and NVIDIA. The strategy is pretty clear. Scale up so enterprises can train their own huge models without handing over all the value to the big vendors.
And what's so fascinating is that this arms race is actually forcing hardware to diversify, which feels like a huge shift.
It is.
For years, the story was just NVIDIA, NVIDIA, NVIDIA.
Yeah.
Now we're seeing, signs of a multi-chip world. OpenAI is working with AMD and Broadcom.
Which suggests they're looking for different ways to optimize to get an edge beyond the standard stack. And NVIDIA is fighting back, but strategically. Well, they know the big cloud players, Microsoft, Amazon, Google, are all using or developing ARM-based CPUs for efficiency. So NVIDIA just made their NVLink tech compatible with ARM.
So that makes it way easier to pair those CPUs with NVIDIA's GPUs.
Exactly. It reduces bottlenecks and keeps NVIDIA right at the center of things, even if the CPU architecture changes underneath them.
Okay, so with all this money and hardware, where does the actual model battle stand right now?
Well, we're tracking two main strategies. On one side, you have xAI's Grok 4.1.
Which is currently at the top of LMArena, right? That's the leaderboard based on what humans prefer to chat with.
That's the one. And their focus seems pretty clear. They're aiming for the consumer market, the companion AI. They talk a lot about emotional intelligence and creative writing.
The conversational companion.
Yep. And then on the other side, you've got the new Gemini 3 from Google, which has just, it's absolutely shattered the benchmarks for raw intelligence.
It's a huge breakthrough, isn't it?
Massive. It hit a 1501 ELO on LMArena, which is a huge jump. But look at the academic scores. 91.9% on GPQA Diamond. That's the gold standard for expert-level scientific reasoning. And 81% on MMMU Pro, which tests really complex multimodal tasks.
So blending vision, text, all of it together.
Exactly. It just proves that when you throw all that capital at infrastructure the right way, you get a direct, measurable leap in what these things can do.
That brings us to what might be the most counterintuitive takeaway from all this. this idea that foundational models had peaked.
The scaling wall.
The scaling wall. That idea has just been completely, utterly debunked.
And what's so wild is the key data point behind that conclusion. Gemini 3 shows that the scaling laws for pre-training are 100% intact.
But people were speculating that performance was slowing down.
They were. But here's the kicker. Gemini 3 achieved these huge performance gains while having the exact same parameter count as Gemini 2.5, its predecessor.
Wait, hold on. Same parameter count, but a massive jump in capability. How is that even possible? It's like having the same size engine in a car, but suddenly it has 3 times the horsepower.
That's a perfect analogy. The secret is in the pre-training and the post-training. The insight is that it's not about the absolute number of parameters.
It's about efficiency.
It's about coherent FLOPs, or computational efficiency. So you're not building a bigger engine. You're tuning the one you have so perfectly that every single cycle contributes something meaningful. The scaling wall was a mirage.
So if I'm a user or a business trying to figure out which of these new giants to use, how do they stack up? Give us the quick comparison, say, between the new GPT 5.1 Pro and Gemini 3.
Sure. Think of them like specialized contractors you'd hire. GPT 5.1 Pro is your slow, heavyweight reasoning model.
Okay.
He's the contract engineer for deep, multi-step thinking, complex planning, research. It's amazing for that deep, narrow focus, but it's expensive and it's slow.
And Gemini 3?
Gemini 3 is better for most day-to-day work. It's faster, it's more consistent across a whole range of tasks. But, and this is a big but its performance really depends on how you prompt it.
So prompt engineering is moving from an art to a real science. Tell us what works.
It absolutely is. So first, it wants direct, structured prompts. You have to put your behavioral constraints like act as an expert historian right at the top.
Don't bury them.
Don't bury them. Second, it's concise by default. If you want a conversation, you have to explicitly ask for it. And finally, for those huge, long context inputs, put your instructions after all the data.
Oh, that's interesting. So it focuses on the data first, then looks for the instruction.
Exactly. And one last thing on structure. It loves explicit planning steps. If you tell it to use, say, XML tags for plan and then critique.
A self-critique loop.
A self-critique loop. The quality of its reasoning just skyrockets.
The detailed advice really just highlights how we're moving past simple chatbots, aren't we? We're heading into a world of specialized tools.
This is the big economic pivot. We're moving from model labs that sell tokens for chat to agent labs that sell outcomes. Completed work, analyzed data, working code. The cash flow economics on that are just fundamentally better.
And we've seen some amazing examples of this specialization, especially with coding, like GPT 5.1 Codex Max. This isn't just generating little snippets of code.
Not at all. It's trained for what they call compaction.
Compaction.
It's a way for the model to summarize its own work history so it can operate over millions of tokens of context. It lets the agent work on a problem for 24 hours or more.
That's why it's scoring so high, like 77.9% on SW Bench. It's solving real bugs from GitHub.
This is real-world competence. And Google's answer is the Anti-Gravity IDE. It's a free version of VS Code built for Gemini 3 that runs multiple autonomous agents at the same time.
So it's not just you talking to an AI.
No, it's you collaborating with a team of AI agents. They have access to your editor, your terminal, your browser, and they generate artifacts, task lists, screenshots, recordings to document their work. It's a whole new way of working.
And this is all getting so complex, we actually need new benchmarks like Klein Bench just to see how these agents break down in the real world.
And that need for complexity is even more intense in science. The most mind-blowing example we saw was the Cosmos AI scientist.
From Future House or Edison Scientific now.
Right. This system reads 1,500 scientific papers and runs 42,000 lines of analysis code in a single run.
One run. How much human work is that?
The beta users estimate that one run, which costs about $200, does the equivalent of 6 months of work for a human researcher.
6 months of work for $200.
And it's already made 7 novel scientific discoveries. One was even validated in human tissue for Alzheimer's research. It's just an exponential compression of time.
We're also seeing this in the visual space, too, with Meta open sourcing SAM 3.
Yes, the segmentation model 3. It can now precisely isolate and track objects across video using just text or visual prompts.
Which enables all sorts of flexible media workflows that were, basically impossible before without tons of manual effort.
Total game changer for video editing and analysis.
Okay, we've established the money is huge, the tech is accelerating, the scaling wall was a fluke, but there are also some pretty critical operational gaps and economic challenges bubbling up.
For sure.
Let's start with what seems like a massive, surprising blunder from Google.
It's a classic case of having the best hand and being too afraid to play it. Google is sitting on the strongest context position in the world. Workspace, Maps, Search, Gmail, all of it.
They could power a truly personal AI.
They could, but they're dramatically undercapitalizing on it. Operationally, Gemini hides its workspace connector deep in the settings.
They treat it like an afterthought, not the core product.
Exactly. It's almost certainly because of internal safety and privacy fears, fear of backlash. But by playing it so safe, they're missing the chance to create intelligence experiences that would be impossible anywhere else.
So they have the keys to the kingdom, but they're afraid to unlock the door. Meanwhile, the entire hardware foundation of the industry is facing its own potential crisis, right?
This is a really important question. Can the hyperscalers keep this pace up? GPU depreciation is a very real threat.
Meaning the hardware becomes obsolete too fast.
So fast. If the new Blackwell chip is twice as good as the Hopper, your billion-dollar data center full of Hoppers just lost half its competitive lifespan overnight. It's a dangerous financial ticking clock, especially when you add in spiking electricity costs.
And speaking of financial clocks, we heard a pretty sobering take from the CEO of Hugging Face.
Yeah, Clem DeLange. He argues that the LLM bubble, this rush to build one giant model to rule them all, might be bursting next year.
But not the overall AI bubble.
Exactly. He's very clear. LLMs are just one part of AI. He thinks the future isn't one big model, it's a multitude of smaller, specialized models solving specific problems. The winners will be the ones who master efficiency and specialization.
Wow, what an incredible survey of the field right now. So to sort of synthesize this for you, we've seen three huge shifts happening all at once.
Yeah.
First, this insane competitive investment in infrastructure. Second, proof that scaling is alive and well through better training. The scaling wall was a mirage.
It was.
And third, this massive pivot from general chatbots to highly specialized autonomous agents that do real work.
And that dynamic, that tension between centralized power and decentralized efficiency, that leads us to a final thought for you to chew on.
Oh,
We know the hardware crisis, the GPU depreciation, is a real economic risk. But at the same time, the intelligence of small models running locally on your devices.
unlike Apple's M-series chips using MLX.
Exactly. That performance gap with the giant cloud models is shrinking. So how quickly will that shift the strain away from the electric grid and these huge centralized data centers?
That's a great question. Should the long-term investment focus shift from building these massive, power-hungry data centers to just optimizing intelligence per watt for local AI?
It's a powerful thought to consider.
It really is. Thank you for joining us for this look at the state of AI today.
Spoken Tech for your ears.